Welcome back to All This Math. This is Professor Parker. And make sure you subscribe to the All This Math YouTube channel. Make sure you drop a comment below, like the video, share the video with some other people, some of your classmates or something. All right. Now, what are we getting into today? We're getting into figuring out polynomial end behavior, right? End behavior. Now, end behavior is what it sounds like. When we look at the graph of a polynomial, like what does it look like where the arrows are at, right? Does it go down over here? Does it go up over here? Does it go up over here? Does it go down over here? Here's our like coordinate plane right here, right? Here's our coordinate plane, you know, y-axis, x-axis. Now, so it's basically like, you're looking at a graph, right? So if I had a graph that looked like this, right, the end behavior would be it goes up to the left and it goes up to the right on the ends. Like, what's it looking like on the ends? That's what end behavior means. What is it looking like on the ends? This marker almost dead. Get him out of here. Not using that no more. Yeah, can't even see that. But yeah, the end behavior. Like, what does it look like at the ends? What does it look like, right? Because this is key information where we're going to graph polynomials. Now, especially when we get up into like polynomials with exponents or degrees that are bigger than 3, or bigger than 2 actually. Because if it's quadratic, it's just going to be a parabola, right? It's going to look like a U or upside down U. If it's linear, it's going to be a straight line. That's kind of light. But when you start getting into polynomials that have the biggest exponent of a 3, like x to the third plus whatever, whatever, or like here we got x to the fifth plus 2x squared minus 3x, and like, you know what I'm saying? It gets a little more tricky. So we start talking about end behavior. All right, so look, I got 2 examples up here, and it's 2 pieces of information we need in order to tell the end behavior. We need to know what the lead coefficient is, the lead coefficient, right? The coefficient that's in the beginning of the expression. So number one, well, let's talk about both things. So I'm gonna say LC, that's lead coefficient. So we need to know what that is, the lead coefficient. And we need to know the degree. All right, so the lead coefficient and the degree. All right, so in number one, the lead coefficient is this -2 right here. Now, number one looks a little different than you might be used to because most of your expressions or your functions will look like this. But this is just in factored form already. This is given to us in factored form. X minus 5 is a factor. X plus 6 is a factor. X minus 3 is a factor. X plus 2 is a factor. Now, it's only one of these X minus 5s with an invisible exponent 1. It's only one of these X plus 6s. It's 2 of these X minus 3s because that exponent 2. It's 3 of these X plus 2s. That means our degree, let's talk about that first. Our degree is going to be 3 plus 2 is 5 plus 1 is 6 plus 1 is 7. So our degree is 7, all right, which is an odd number. That's an odd number. That's important. When you find your degree, all you really care about is it odd or even? Is it odd or even? That's all you really care about. Is it odd or even? All right. Our degree is 7, and that's an odd number. Now, what's my lead coefficient? It's a -2. My lead coefficient is a -2. Now, in terms of the lead coefficient, you only care about whether it's positive or negative. That's what you care about. So with my degree, is it odd or even? With my lead coefficient, is it positive or negative? All right. So look, because the degree is odd, right? If the degree is odd, your function is either going to go like this or it's going to do the opposite. It's going to go like that. One of these two. One of these two. Whenever the degree is odd, so whether it's a 7, a 5, a 9, 11, a 13, a 1, well, not 1, but well, I guess yeah, 1 because that's linear though. But it's going to be one of these two. Now, how do you know which one of these two it's going to be? You go to your lead coefficient. If your lead coefficient is negative, that means you're going down to the right. You're going down to the right. You're going down to the right. All right. All right. So you're going down to the right. So as you look at the graph going from left to right, you're going down to the right. So the end behavior of this function is going to look like this. It's going to go up to the left, down to the right, up to the left, down to the right. Now, but how do we say that though? Like, how do we say that? What we say is we say it like this. We say as the x values approach infinity, the y values or the f of x values, right? What are they doing, right? So as x becomes positive, as x gets more and more positive, what's happening to the y values? They're going down. They're going down. They're going to keep going down forever and ever and ever, right? So that means f of x is going to approach negative infinity. Make sure you understand that. As x gets bigger and bigger and bigger, right? So imagine this is your graph, right? We ain't worried about this one. Imagine this is your graph right here, right? This is your graph right here, right? As the x values, as you count the x values, you're getting bigger and bigger. You're going from 1 to 2 to 3 to 4 to 5 to 6 to 20 to 40 to 60 to 80, 100, whatever. What's happening to the y values? They're going downhill. They're going downhill, 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 right? So that means they're getting smaller and smaller. They're going all the way down to negative infinity, all right? Now, what about as x goes to negative infinity, right? Because x is also going to negative infinity. So that means as x goes this way, to the left, what's happening to the y values? The y values, and remember, y and f of x are the same thing. So your f of x is going to become positive infinity. You don't got to put the plus sign, but I do. Like I ain't put it up here, but I just put it up here just, I guess, just to be extra, right? So as x approaches negative infinity, meaning your x values are going that way, what's happening to your y values? They're going up. They're going up because you're really going like this. Your x values are getting bigger, bigger and bigger and bigger. And what's happening to your y values? They're getting bigger too. They're going to go all the way up to positive infinity. And as your x values get smaller and smaller and go to negative infinity, what's going to happen to your y values? They're getting smaller and smaller and smaller. So they're going to negative infinity. So that's technically how you would write that. All right. That's technically how you would write that. All right. So that's the first example. Let's look at the second example. Well, the second example, again, lead coefficient. What's the lead coefficient? An invisible one right there. An invisible one. An invisible one in front of the term with the biggest exponent. Exponent 5, exponent 2, exponent 1. So that's the lead coefficient. So your lead coefficient is 1 and it's positive. That's a positive number, right? What's your degree? Your biggest exponent is a 5. That's an odd number. This degree is a 5. So that's an odd number. Since that's an odd number, that means it's going to look like one of these, right? But your lead coefficient is positive. So now you're going this way. You're going up to the right, up to the right, up to the right. If your lead coefficient is positive, you're going, and your degree is odd, you're going up to the right. I should have picked an example where we had a even degree and an odd degree, but I'm gonna do another video for that. All right, so look. So now, how do we write it up though? As x approaches infinity, what's happening? What's f of x doing? Look, as x approaches infinity. So as x goes to the positive side, x gets bigger and bigger and bigger and bigger, right? My x value is getting bigger and bigger. What's happening to my y values? They getting bigger too. So they going to infinity also. But what happens as x goes to negative infinity? What's happening? What's happening? X is getting smaller and smaller, smaller and smaller, smaller and smaller. What's happening to y? Y is getting smaller and smaller. So they both doing the same thing. They both doing the same thing. All right, so they're doing the same thing. All right, so that's how you find end behavior. That's how you find end behavior. You got to identify the lead coefficient. In this case, in number 1, it was -2. Identify the degree. The degree is the largest exponent that you see. Now, if this was multiplied all the way out, your degree would be 7, right? Because of that 3, that 2, that invisible 1, and that invisible 1. The degree would be 7. The lead coefficient is already -2. In this one, your lead coefficient is a +1, and your degree is a +5. So it's odd. They both odd. Both of these examples were odd. So when it's odd, it's going to look like this, or some type of variation. It might look different in the middle, but on the ends, it's going to look like that. One arrow going down, one arrow going up, right? One arrow going down, one arrow going up. And how do you know which one is which one it is? It's based on whether your lead coefficient is positive or negative. Positive or negative. And then you got to write it up like this. All right. But if you need to, review how I got this answer right here, this part over here, or this part over here, just hit rewind. It's cool. Just hit rewind. All right. So awesome. Shout out to Fred Hampton. Definitely shout out to Fred Hampton. I'm recording this video on December 4th, 2024. This is the anniversary of when he was assassinated, him and Mark Clark, over in Chicago, back in, I want to say 1969. Yeah, 1969. That's when he was assassinated. Brother was the leader of the Chicago branch of the Black Panther Party for Self-Defense. If you're not too familiar with him, definitely go do your research. Find out some information on Chairman Fred Hampton. All right. I'll see y'all on the next video. Peace.